All right.
So
So I was talking to Wayne before because I'm trying to build some training, and I want to make sure I have everything correct. And the problem I'm having is some scope you look at the manufacturer, and for liquid piping, I mean the suction piping is typically always still the end. It's still the way it always is. Basically, you feed it into the top, right? Helps with boiling off some of that refrigerant that you might have liquid laying around, and just kind of atomizes that oil a little bit. But then with the liquid piping, most of the time we're all used to everything pulls off the bottom, everything, as far as the liquid. But then when I'm looking through a lot of the spec, I start seeing, okay, Kaiser's like, oh, I want to feed off the side. I think Zero Zone the same. I looked at some plans for one or two customers, and they're showing pull off the side. So I started asking those questions because I want to make sure I get it right. But I want to talk about this for a little bit and see what your thoughts are.
Yeah, so I mean, as we touched, I think predominantly our go-to is bottom for liquid, to be honest. I think like we discussed on it, the side is not a problem. There's two factors that you need to consider when you look at the pipe sizing or piping of the system. Like we said, CO2 is fairly sensitive to pressure drop. The main reason being, no matter what subcooling you gain from your gas cooler outlet or condenser when you're in a subcritical mode, as soon as you expand through your high pressure valve, basically at a saturated liquid. So if you do not subcool, predominantly you will see your refrigeration systems either have the flash gas going over the liquid, get some 2K or 3K subcooling out of it. A lot of times you get your superheat out of your LT coming back. Use that to subcool your liquid. So the main reason for that is to basically give you buying yourself a buffer. Because if you're right on a saturated, any pressure drop is going to start flashing. So you're going to start getting your liquid flashing into vapor. So if you're going to pull up, the higher you pull up out of the pipe, obviously your vapor is sitting at the top. You're going to pull that vapor out with your liquid going to a certain case. I mean, that vapor needs to end up somewhere. So like we said, usually if you have that problem, you'll see it at end of line. Like you're either short of gas or you flashing too much, your pressure drops too high. You'll see it end of line. The second factor that you need to consider, what we said, is depends on the type of oil, but the same as your suction, it's your oil carry. So POE, highly miscible, and CO2 carries very well. So in your liquid side, that's not an issue. If you have bag in your system, your typical liquid temperature, your bag is going to be at the bottom. So you would like to feed that bag with. So that can be something that maybe that I can consider is when we do look at bag, you might want to take out of the side so that you don't slug all your oil to the first case. So that can be a reason for sidetrack. So it would be a good question to ask or to find out that where it is typically specified to take it out of the side, if that is a pack-based system or a POE-based system. If it's POE, I would say go out the bottom, make sure that the vapor heat, that last case, helps with fault finding. Um, and a full bore of liquid is number one for an expansion, especially electronic expansion device.
So
Um,
because of what you said, as far as the liquid being essentially a saturated liquid, where you don't really have much subcooling there at the bottom of the flash tank, you might get like we talked about 2 or 3 degrees Fahrenheit of actual subcooling on there. So that's what I originally thought. I thought maybe because it's a shittier quality of liquid, because we're essentially manipulating the CO2 to make it do what we want it to do, right? As far as out of the HPV, we understand that yes, in subcritical mode, we have like a 70-30 mix, 70% just about liquid, 30% vapor. And as we go to transcritical, it's more like a 50-50, somewhere in that range. Right.
yeah,
But so if you had, that's why I'm assuming that's why a lot of manufacturers, typically use the suction of the low temp to typically additionally subcool the liquid either on the drain leg or, potentially, coming out of the actual, out of the flash tank, so you get that additional subcooling, so you have a little bit better of a quality of liquid. Would that be an apt description?
yeah, exactly. So I mean, if you have anything that you can, it's a benefit. Firstly, you can reduce your required superheat at your evaporator. So it's two-sided win. I mean, if you can run a DX, if you run a DX system and you can reduce the superheat required at your compressor or at your evaporator, sorry, that's a benefit. You gain that superheat, number one, and number two, you gain that additional what you can call subcooling. So all that means is you're basically pulling yourself out of that saturated curve into the liquid side of life, meaning that if you have a half a bar or whatever pressure drop on your liquid line supply, you're not going to start flashing. You're giving yourself that buffer. And also, like, I mean, you're moving flash gas, so that's another thing that you need to understand. Like the flash gas in a system is actually very interesting. I mean, that comes back to the high ambient strategies. Like every high ambient strategy is based around taking care of the flash tank in the receiver. But one benefit, and it comes to the low side of life, is where CO2 really gets the benefit of having the flash tank, because we need to consider that flash tank is not a CO2, flash gas is not a CO2 thing, it's any refrigerant. As soon as you have a pressure drop and you go into your two-phase region, you separate vapor from liquid. So basically, with CO2, you do a lot of that in your high pressure, in your receiver tank or your separation vessel. But what that means is you're feeding a constant liquid to your evaporators. So from a design point, it actually supports the design of the evaporator. You can have a much better, your evaporators don't see ambient. So that's the main difference between an HFC system and a CO2 system. Is if you design a CO2 system, you design around making sure you've got the mass flow capacity, compressor capacity, to deal with your fluctuation in flash gas according to ambient conditions. HFC-based system, you need to design your evaporators to take care of your ambient conditions as well, because if your tank there goes higher and your condensing temperature is higher due to ambient, you're going to end up with that 30% flash gas or 40% flash gas entering your evaporator, where in the winter conditions you'll have your 10% entering your evaporator. In a CO2 system, because you have that separation vessel, you're constantly feeding the same pressure temperature to the evaporator. So that evaporator is 365 24/7 seeing the same feed to it. So it makes a good operation on the evaporator side. But yeah, from a piping side of life, yeah, you want to try and reduce that, getting that vapor, and it's always interesting. Like you can hear it. I don't know if you walk through a facility or something or an installation in the beginning, especially if you have the Danfoss valves, which is the solenoid driven valves. Like you
Pulse
can
width
hear
valve.
if you hear those pulse valves, you can hear them click. You're still short on gas, then, or you've got vapor going through your
Really?
expansion device. Yeah, if you hear them click, there's vapor. Otherwise, you shouldn't hear them click that easily.
No shit. I never realized that. Kev, is that a new thing for you too?
They get quieter when
Okay.
when they're especially they even quiet down a lot more when there's more caseload. But yeah, in the beginning, like when the superheat's kind of hunting, when the empty case, the superheat's kind of hunting all over the place. So yeah, that makes sense. But
Gotcha.
I mean the liquid piping, it's interesting. It's just I wonder if it's something with the U.S. manufacturers just not catching up to everything yet. I mean, it seemed like one manufacturer started doing it, then they all started doing it. They all just copied, and every spec looks the exact same.
Like the picture in the one customer prints looks exactly like what's in the Kaiser Warren book. Like it's the same damn picture, same orientation, same thing with the Husman shit. It's literally, I think, the same picture. So I think someone made it and they're like, yep, that's what they're doing. We're gonna do that across the board.
Yeah, same as Hill. If you look at Hill's picture and Zero Zone's picture, it's the same exact thing. So I mean, somebody went across the board. I mean, me personally, I would rather see it off the bottom.
Yeah. Well, so I talked to Ray Kelly about this because before when I met up with him in California, California, we were talking about it, and the idea is that because it's a lower quality of liquid than what you typically get, right, and more susceptible to pressure drop. The idea is that if you evenly give a little bit of case, a little bit of flash gas, then it's not as bad as basically just having total vapor at the end. That was his thought. But I mean, now I'm thinking otherwise. So
Yeah, I mean, my counter on that would be is I would not want to sacrifice little. I would not like to sacrifice 5 to 10% over, I don't know, 50 odd cases. I'd rather see one case completely suffer and now I got a problem that I need to fix, because then I can fix it. Otherwise, otherwise I give it up on all the other cases. It's going to be the same. It's just spread out, and you don't realize it.
Okay, and since we're talking about piping, I just want to ask this question. I was reading through the pump liquid stuff, and I saw, you know, they're really careful with, you know, putting like downsizing the cases so you still have even flow across everything. Is there any difference? Like, I mean, they don't want you to basically start from one end of the case and go to the end. They want you, for pump liquid, they want you to basically start from the middle and then keep going down every single case. Is that have you seen that in the past where they would rather do that, go off the middle and out, rather than start from the end and feed in for the pump liquid? Or if you were to design it, well, how would you do it? Is really the question
You
I'm
mean
asking.
like Sorry, I'm just trying to understand the question. Like, you mean like the how you
Distribute.
distribute to the different cabinets and stuff like that. So
Yes, yes,
not have a ring feed, but rather have a, like, try and split through the center.
yes, yes.
Nah.
See, we've always done first in, last out. So first case to get liquid in is the last case to get suction out, or the vapor return line out. So that way, the first case, just like we would pipe glycol, that's how we've done it. So whatever case gets fed first is the return line is the farthest away. So, I mean, I don't really think it does anything, just for the fact that, I mean, all those cases have solenoids on them. So, I mean, they're going to cycle on and off as needed if a temperature. I mean,
Yeah.
but most of the time that stuff just floats off the vessel.
Yeah, and I mean, and you've got your overfeed ratio that you connect to that. So, I mean, in my opinion, I agree with you, Kevin. Like, typically do it like the similar way. I don't think necessarily you have to do a different configuration than you would do with any other type of pump system. I mean, for me, the main thing with your pump type system is to ensure that you've got your liquid overfeed correct and that you work according to that. Like, yeah. So I must say we've more done pump systems on industrial blast freezing applications.
Hmm.
So it's not so many coils that you have a complete split, but it's more like I say, it's more that getting that overfeed ratio correct and making sure that your pump can handle the high volume and the how can I say it, the discrepancy in requirements according to load.